Welcome friends to this channel Dr.ARM's chemistry. First of all, I want to express the sorry for our delay in the preparation of the videos because of the unfavorable hot environment. I hope you will understand this. Today we will see the next point of the same topic. These metal carbonyls is our continuous topic, and the next point of this topic is metal nitrosyl compounds. Here the metal nitrosyl compounds contain nitrosyl group as a ligand. They contain nitrosyl group as a ligand, and this ligand has one electron. So this has one electron more than carbon than that of carbon monoxide. Means here carbon has 6 electrons in the valence shell and nitrogen has 7 electrons, and that is why there is such difference. So that extra electron is present in the antibonding, that is pi star molecular orbital of this nitric oxide. So it has nitrogen oxygen pi star orbital which contains this electron, and it is thus a 3 electron donor. So therefore it is a 3 electron donor. If we see its equivalence with carbon monoxide, it is found that the 3 carbon monoxides are equivalent to 2 nitrosyl groups if we consider in terms of the electron count. Then nitric oxide, that is NO, can also act as 1 electron donor when the lone pair is residing on nitrogen. Here if we see if there is say such bond, this is metal, and if it is nitrogen and the lone pair is residing on nitrogen, then this oxygen, that is nitric oxide, is having the structure like this, that is the bent form. So when the lone pair resides on the nitrogen and the geometry is bent, so you will find such type of bent geometry. Now, if we see the oxidation state count method, then the ligand is used as a coordinated group in which the ligand nitrosyl group is present as NO plus ion. So nitrosyl, in such case, according to the oxidation state method, the ligand is used as a nitric oxide, that is nitrosyl ion, that is with cation, and in such case when it is nitrosyl group, that is NO plus, if we see the structure of this nitric oxide with oxygen, that is when the metal is coordinated with this nitrosyl group, that is ligand, it shows linear structure, that is linear geometry is observed. Means when this nitric oxide group is having the structure like this, NO plus, it is having the structure like this, that is linear. But when we are having the ligand in the form of NO minus, when we consider this in NO minus, then the structure is metal ligand bond is like this, and it has bent structure, bent form, and this is linear form. So the geometry is in this way correlated with the nature of ion, whether it is cation or anion. We will see some examples which are this is Cp cyclopentadiene, then here it is NO, then this is NO, this is cyclopentadiene. So here you will find that these are two bridging ligands. Nitrosyl ligands are in the bridging form, and these nitrosyl groups are in the linear form. So these are identified with the help of the ion absorption bands. This will show the ion absorptions, means the environment of this NO is different than this bridging ligand. So the terminal ligands are in different structure or different form than the bridging form. So they will distinguish themselves with on the basis of these ion absorption bands. So this NO, when it is linear, it will show absorption at 1672 per centimeter. When this nitrosyl group is bent form, that is bridged, we say bridged, it shows absorption at 1502 per centimeter. So this will explain the difference in bridging and the terminal nitrosyl groups. Now we will see another structure. This R. This is Cl. So here you will find that there are two types of nitrosyl groups here, and these are identified on the basis of infrared absorption data. So you will find that this linear structure shows that is absorption of this NO is taking place at 1845 per centimeter, whereas this bent nitrosyl group shows absorption at 1687 per centimeter. So you will find the difference in ion absorption, and that can be easily correlated with whether it is the bent group or a linear nitrosyl group. Again we will see one more example, a simple example, that is nickel complex with this cyclopentadiene and nitrosyl group. Here also you will find that this nitrosyl group is the linear group and it shows absorption in the similar way as we have seen in the earlier pictures. So this nitrosyl group shows absorption at 1830 per centimeter IR absorption bands. This is 2 electron donor in both linear and bent forms. Although either of this nitrosyl group, so both are having good electron donating ability, means they are good donor atoms, that is they are potential donor atoms. But the accumulation, that is presence of charge on this oxygen is avoided by using nitrogen as the point of attachment with metal. So instead of using this oxygen is more electronegative than nitrogen, but instead of showing this attachment to metal, it is favored to show this. So metal also always coordinates with the nitrosyl group using this nitrogen terminal of nitrosyl group. This is because in order to avoid thermal charge residing on oxygen, because it is more electronegative. Then nitrosyl complexes are readily formed by the replacement of carbon monoxide with nitric oxide. And we see the reactions or the coordinating ability. We see that the nitrosyl compounds are readily formed by replacement of carbonyl group, by replacement of carbonyl groups from carbonyl complexes with nitrosyl. Only few compounds are known with, means only few compounds of organometallic compounds with nitrosyl groups alone, means the stability, this shows that the stability of nitrosyl groups alone in the nitrosyl compounds is very low, and that is why such compounds in which there are only nitrosyl groups are very few. But the mixing of the two ligands, that is carbon monoxide and nitrosyl, are very easy, means we can have the carbonyl compounds complexes having both groups, that is carbon monoxide as well as nitrosyl. So these are obeying 18 electron system. Then it is found that there is one problem regarding the synthesis of nitrosyl complexes. Here it is observed that the excessive concentration of nitric oxide, that is nitrosyl ligand, shows that at the high temperature and pressure the nitrosyl group, that is nitric oxide, is easily decomposed, and there is unfavorable oxidation reactions. Many current synthetic routes shows that there are number of reagents which are used here for providing nitric oxide, that is nitrosyl group. One is nitrosyl chloride. So this nitrosyl group is provided by nitrosyl chloride, that is NOCl. then nitrites and nitrosonium salts. So nitrosyl groups are used in the as a reagent. So these are the reagents for incorporating these nitrosyl groups. Like carbonyl complexes, the nitrosyl complexes are also characterized by using the IR absorption or IR spectroscopy. You see the nitrosyl group. So this can lose one electron and produces NO plus one electron. Then this nitrosyl group there is one unpaired electron. There is one unpaired electron, a pi star antibody orbital, and it shows means this nitrogen oxygen bond is characterized by IR stretching at 1896 per centimeter. In this case, you will find that this can be observed as NO plus and PF6 minus. So here the free NO plus has absorption at 2250 per centimeter, and if we see the metal nitrosyl group, it has this stretching vibration. This shows at 1600 to 1900 per centimeter. It's cyclopentane complex of chromium, Cr, NO twice, Cl, when it is NaBH4. It gives the complex twice. So here it incorporates the Cl is replaced by nitrosyl group as the bridging group. So with this we will complete this point and we will go to the next point in the next lecture. Till then, goodbye. See you next time. Please subscribe to the channel and also press the like button, for this will help us to improve our efficiency. And if we want to add, or if we wish to add any point as per your choice, you can put your comments in the comment box. So see you, goodbye.